I have a set of slides about the method behind Leximancer, what it's doing. There were some questions coming in from when people registered that indicated that people might want to know more about the method. But if that isn't you, then please let me know. So Leximancer is a tool for analyzing text content. It's like a qualitative analysis tool, but only for text. It's designed to model language. So you put in data and it creates a model automatically of the content. Text is unusual sort of data. It's not like any quantitative data people usually meet. Text forms a particular type of network, actually, called a small world network, which you might have come across, particularly maybe 15 years ago, when there was a lot of talk about it. So Leximancer adopts a small world network model to analyze text because that's best practice. I mean, because natural language forms a small world network, and we know that the research is very conclusive about that, you really should model it that way. And Leximancer is really one of the few tools that does model text in that way. And this might explain why the models you get out of Leximancer are not quite what you might have expected, from using statistical analysis or doing quantitative analysis, or even using NVivo, because NVivo really doesn't really analyze text, doesn't model text in that way. So how do we do this? Well, it's a method of automatic content analysis. Leximancer's entire purpose is to let the data generate a model, a transparent model which you can see every part of, so you can understand how a concept is defined and where it's coded into the data. And it's to enable you, it's to empower you as the analyst or the researcher. It's not the AI that you might think of that automatically does something, that automates a task. It doesn't automatically create a report for you. It's a tool so you can efficiently conduct a sense making of potentially a large amount of text. It builds a model of the information space. And the method it uses is a type of content analysis. Content analysis basically codes text. But that's putting it very simply. A content analyst has to first develop what's called a code book. It's just a set of concepts that you care about, that you want to measure in the data. You can't measure everything. You can't measure everything in any situation, any experiment, any set of data, any artifact in the world. There's no way you can measure everything about it. So being a scientist requires that you make choices about what you measure. And so Leximancer does make choices about what it codes in the text. These are driven by the text statistics, by word co-occurrence counts, word frequency, word correlation statistics. Basically, the words that appear pretty often, but have a lot of other words that are associated with it, a large vocabulary or that describe that idea. And the more words that describe an idea, the more important it is, and the more it comes up the Leximancer ranking. So it has a strategy, an algorithm, if you like, a method for finding the words, the concepts that are important in the text. But you don't necessarily have to agree with that. So, we'll see that Leximancer tries to discover a small number of concepts that cover most of the data. But you might want concepts that cover just a small part of the data. You might want to look at a particular topic and code a particular topic theme. And you can certainly do that, but that's an advanced setting where you take control of the model. So let's continue. Content analysis, it determines the presence of words or concepts in your collection of text, that code book. And it breaks down the text into chunks. So every 2 sentences, and it codes it with the concepts that are indicated. So you still have to do some things with content analysis. You still have to decide your sampling. So do you have enough content from the population? What is the population? What's your research question? If you're trying to advise public policy for a whole country, then you need a fairly wide scale sampling of all the different demographics and you know, the regions, the social types, the genders, etc. in your country. You would have to sample text from all of them to give your recommendations sufficient power. Whereas if you're just doing research on a group, a work group in a company, a small organization, then all you need to do is interview or get data from just the work group, and you can the population is small, and you can get data from just those people. So sampling is still your call. For a content analyst, you need to decide what segment of data is when you're coding. So you might code a whole newspaper article or just a sentence. Leximancer codes every 2 sentences of text by default. That's its unit of analysis. And then the third question is, what constitutes the concepts? And I've already mentioned that you can't measure everything. You can't look at every word in a body of text. Well, that's more than, say, a page, because the vocabulary can be 10,000, 20,000, 100,000 words. That's unique words. And you can't look at all of them. So working out what to measure in your text is important. And in automatic mode, Leximancer makes a decision about that, a decision that tries to cover the whole text with a moderate number of concepts. Now, how does Leximancer discover a concept from text? It's a good question. We talk about concepts. A lot of people in the industry talk about concepts when they really mean words. But that's not true with Lex. Leximancer discovers and builds concepts from the text itself. So it doesn't have predefined dictionaries. It doesn't come loaded with a list of words that means that it thinks means certain things. And it doesn't do that because that's not really possible. You can't tell what a word will mean in advance of seeing the data and the community that's using the word. So words mean different things in different contexts. And context is dominating. It's a dominating influence in language. The context dictates what words you should use and what words mean when you use them. So this is an example of a latent concept that you see on screen. So Lex pulls latent concepts out of the text. If you're interested, the latent concepts and latent semantic indexing and latent semantic analysis are recognized research methods, and there are other ways to discover latent concepts from text. But we think we have a superior way of doing that because the way Leximancer does it suits the small world nature of language data. So this is a latent concept that's pulled out of a document. The concept name is rifle. The words that define it are a list of weighted terms. And in any Leximancer map, you can see a Leximancer thesaurus, which has many concepts many latent concepts which are extracted from the data itself to give you maximum relevancy. So once you've got that set of concepts, how are they used? Why do we bother? Well, why we bother is that if you have a survey or a set of journal articles or any larger collection of text, you need a way to group the words together into ideas. There are too many words to model each one separately, and there are, an idea can be indicated by quite a lot of different words. We use multiple words to indicate an idea. So a larger data set, you need a way to map multiple words down to particular ideas. So this is a list of words which indicate the idea of a firearm in this data. And so what it does with that, Leximancer codes every text segment. So it takes two sentences and says, okay, if that text contains bolt action, Irving Sports Shop, Western cartridge, a sling, a Mauser, then those words are indicating a firearm, and it will code the piece of text with rifle. So this is a way to code lots of different words with an idea that they represent or indicate. And that's what it does. So it does the coding. It classifies or tags each segment of text with the concepts that are present in it. And then it counts. So how many times does the code rifle appear? How many times does the code rifle appear with building or like Kennedy or Lee Harvey Oswald? I say that because this was actually learned from the report into the assassination of President Kennedy. So that's where that data comes from. So once the data is coded, Leximancer will count concept co-occurrences and occurrences and do the bookkeeping on that. You don't have to worry about intercoder reliability. So that part of content analysis, you don't have to worry about with Leximancer because it does the coding. What you have to do is make sense of the results. So let's move on. This is just so you can see what coding kind of might look like. These are examples of coded text segments where each text segment has been coded with the ideas that are indicated. So over the years, content analysis has been used in several ways. There are, I guess, roughly 3 generations of content analysis. The first one just looked at frequency. What was the most frequent concept? What's the second most frequent? And how did those frequencies change, let's say, with time or with region or with author? So it just looks at counts. You can think of, in modern terms, the Wordle, the word cloud, is really just a frequency cloud of word usage. So word clouds or Wordles are, and you see those on lots of websites and places, they're just an example of first generation frequency-based analysis. But content analysts decided they could do better than that. They could look at the relationships between concepts. So how often are 2 ideas mentioned together? And that starts to tell a story. It gives you those relationships. We would say that's a second order model because you're looking at relationships between 2 concepts rather than just a single frequency. It's more expressive. It can start to tell you a story. And disambiguation, what do we mean by that? Well, if I have a concept like culture, you might wonder, how is it being used? And so if you have a concept which is like sporting, you can see how many times does culture and sporting occur together to see if, well, they talk about sporting culture, or are they talking about indigenous culture or European culture? So the concepts co-occurring can give you a more complex story of how those are being used. So, and that is where we introduce this idea of, so if we're doing relational analysis, and if Leximancer counts how many times 2 concepts co-occur, and it does that for every pair of concepts, that's a network, right? A network is simply taking items and linking every pair of them together. How strongly are they linked? So that's a network, and that can become a small world network, which is like the native data structure for text, for natural language. So this is where the idea of making it a small world network came into play. Because we're looking at relationships between pairs of concepts, we can then model it as a small world network, which is a good thing to do for natural language. So then content analysts moved on and said, well, okay, we've got this network. We've got this semantic network, or this concept network. Can we visualize it? Can we take a snapshot of it? So they did what was called a cognitive map. There are other words for it. It could be a projection mapping. It can be multidimensional scaling. And multidimensional scaling is a very common research method for looking at these sorts of models. And if you want to read about that, there's plenty of literature on MDS or multidimensional scaling out there, whole books on it. And it's probably a good idea to have a look at some of that, because it takes you through how to do sense making from one of these models. And it will help you. It will help you using Leximancer maps. It's a type of visually oriented sense making. So we've got concepts coded into text. We've got a concept network built from the data. And then we've got a visualization called a concept map. Now a concept map, here's a simple concept map, not one Leximancer created. This was created by market researchers in a journal article, which you can see there. But I'm showing it to just take you through some of the ideas. Now, you may or may not have seen a concept map before. Concept maps pretend to be simple. They pretend to be self-explanatory, but they're not as simple as they might appear. So, for example, how do I decide what one of the bubbles, one of these ovals, what constitutes them? How did it decide that lime green would be its own bubble instead of being grouped with silver and just lumped in amongst neat colors? So instead of this being one theme or one idea, why was it separated out? How did they choose which themes or which ideas to put in their concept map? And they probably ignored others. How did they choose to do that? So what is a theme is an important decision. And that goes back to what's in my code book as a content analyst. What am I choosing to measure? So then there are lines, there are connections between these. And you can see some have 3 lines, some have 2, and some have 1. What do they mean? And what are they meant to do, really? Well, what they mean is that there are some data connects together neat colors with lime green as a narrative, a story. And I'll come back to this. This is the aim. With quantitative data, you can, you are forced to choose a method of analysis. Maybe you're doing regression analysis. Maybe you're doing neural network modeling. Maybe you're doing, I don't know, maybe you're just creating a pie chart. With this sorts of network modeling, and by network here, I'm referring specifically to natural language because it is inherently a network data structure, a small world network data structure. And it's really important not to lose sight of that. My opinion is that if you use a model for text data which is not network oriented, then you are probably not modeling it appropriately, in my opinion, because of the statistics, the small world statistics, the scale-free statistics of frequency of occurrence, frequency of co-occurrence. So this is a way of looking at a network. And these links are common links in the network, and they correspond to narrative elements. People are saying, when they're creating their network, when this data was created, neat colors includes lime green. It also includes silver, and it refers to the Volkswagen Beetle. There are other narratives which people have linked when they connected up their network to make their language. They connected Volkswagen Beetle to being inexpensive. You can see the line there. And by that, they meant good gas mileage of maybe 30 miles per gallon in the city. So that's a story that people linked together. But they also linked that it was expensive because it had a low price. So each of these is a narrative that is coming out of the text. So this is why these are good models of text, is because they are network oriented, and so is the data they're modeling. There's also distance. Distance is an important dimension on the map. These are, well, if you've ever done factor analysis, there are dimensions. So like if you look top to bottom, there's a dimension operating there. So let's try and work out what it is. How do the concepts at the top differ from the concepts at the bottom? So these concepts are very practical. You've got inexpensive, sticker price, mileage. Let's compare that to those at the top, where you've got neat colors, fun to drive. They're aesthetic. They're emotional, if you like. They're emotionally driven, whereas these are practically driven. So distance is important on one of these maps. So you can see there's this dimension of practicality, and that probably segments the population. You could think that maybe perhaps males will be focused on the practical and females on the aesthetic. Maybe that's stereotyping, but it would be, one of the things you might look for. Yes, are there any questions?
No, just okay. Mary has to leave.
I saw. So that's the concept map. Well, that's a concept map. So Leximancer is nothing more than a system which performs most of the steps of content analysis for you, the user. You still have to work out what your research question is, get your data, and then make sense of the model that it builds for you. This is an example of a model that Leximancer has built from some text. You can see here's the concept map, and perhaps more complicated than you expected if you haven't seen one before. But that's because any moderate sized collection of text is a complicated information space. It really is. Each of these connections has data supporting it. They're all based in real links. These are not they're not a virtual artifact in the model. There are connections between every one of these pairs of concepts forming these narrative chains. So this data set is fairly large. It's about 22 days of transcript from a commission of inquiry. My comment here was that the concepts, what we're talking about here is a concept network. The concepts are building blocks that people glue together into a network to make a model of what they were trying to say. And Leximancer tries to extract that back out of the text to form a network so you can inspect it and you can use it to ask questions. What is the theme down here about? What are these themes about? What are these connections here between these three concepts? What are they about? What's that story that's forming there? So these are the questions that you can ask when you've got this sort of model. It's a network. So if you think about it as a network, what are the most central concepts? How are they connected? Why? And the chains that form in the network. What's the narrative, the stories that they're telling? And you test those by drilling down to the text, by telling Leximancer, show me the text that supports these concepts. Okay, so with Leximancer, it's great for looking at expert language usage. And sure, you can use it for customer feedback, and it's great for that. How the customers are framing their opinions, their emotions. What are they feeling strongly about? But you can use it for publications. So research publications, you can get hundreds and hundreds of journal articles and do a formal analysis or a systematic analysis with Leximancer of the thematic structure within a research literature. Of course, as you know, as a PhD student or a researcher, you might use it for literature review, But a lot of people use Leximancer to actually create publications. They'll do a more formal review, and they'll publish the results. We just found a nice paper which came out just very recently in the last month on sustainability and knowledge management and sustainability, which used Leximancer. And that hasn't appeared on our website yet, but I can show you that in a minute if you're interested. So yeah, publications, surveys. So a survey usually comes in as a spreadsheet. If you've got a spreadsheet in Leximancer, just export it from Excel as a CSV file, that's comma separated values, and load into Leximancer. And we will analyze it readily for you, including the categorical variables. So if you have demographic variables like gender or satisfaction score in your survey, Lex will pull those into the analysis along with the concepts from their comments. You can also use it for looking at media, newspaper, transcripts from radio or television, also Hansard, like transcripts of Parliament. You can see some very interesting strategies that the politicians use when they're framing a debate around an issue. You can also use it for inquiry submissions. So like the Parliament, the Productivity Commission at the federal level, every state government, they call for submissions to their inquiries. And usually, they'll get hundreds and hundreds of PDFs or documents. And you can usually download those. And it's really interesting to do various types of Leximancer analysis on those submissions to inquiries. It can give you a cross-sectional view of particular areas of society, research interests. So yeah, so that's type of analysis that I don't see as much. I see a lot of surveys and publications, interviews, but it really is rewarding to look at inquiry submissions, to look at the strategies that are being used in the communication. So if you're interested in learning more about content analysis, there's a really good book, good because it's short as well as well written and deals with everything you really need to know about content analysis. It's Basic Content Analysis by Weber. And so in terms of Leximancer validation, this paper here, Smith and Humphreys, 2006, was a method validation paper published in peer-reviewed literature, Behavior Research Methods. It's on our website. It's fairly technical, but it is a long, thorough validation of the tool as a research method. Now, there are just a couple of examples of good articles which use Leximancer to publish with. There are plenty more on our website on the science link. So on the leximancer.com webpage, if you go to science, you'll find quite a lot of, a whole list over the years of papers I liked which use Leximancer. And if you can't find anything there that you want, just go to Google Scholar and search for Leximancer and whatever your research discipline happens to be. Leximancer in education or Leximancer in business. And you should find something, because there are 3,000 or 4,000 references out there now which use Leximancer. All right, so that's just contact details, and so that's it for the slides. It's a nice paper, Knowledge Management in Society 5.0, Sustainability Perspective. It's quite a good example of a Leximancer analysis. So yeah, so it's actually a formal literature review. So they've got a bit of a model of their process, collecting their data. So it's sampling, Yep. And then just, right. So this is their overall concept map of the papers analyzed. And they've got a nice separation here. You can see various types of capital, human capital, economic capital, financial capital associated with development. Down this end, got a clear factor happening along this dimension, going from knowledge to capital via, okay, so what I can see here is social resources and society and resources here, systemic issues, innovation. And just quickly reading their paper, they identify that knowledge is kind of the keystone to society being able to manage its resources going forward in a time where resources become more and more constrained. They do some nice work here, pulling out these tables of themes. So, so these bullet point breakdowns of themes are repeated various points. And I like that. These kind of encapsulate, this is a real sense making. So this is a good outcome of doing a sense making of a Leximancer concept map, is put in your own words what the important themes are from the data. So from exploring that concept network and drilling down to text, these are conclusions that you can draw. And you could support these with quotes from the text. And you could quantify them to a degree in that you could rank them as most important to least important. But remember, this is qualitative. It is not quantitative data as such. So yeah, that's quite a nice piece of research. All right, so I might go and open up a concept map now, so we can have a look at a real map. Let's go and find that. Where did I put it? Hopefully this is it. All right. So this is a Leximancer concept map. And what I might do is I might just go and recreate it. So you can see the process right from the start. So when you open up Leximancer for the first time, it looks like this. These are the places your projects live. And you won't have any folders here, but I do. So I've got folders for my projects. And if I select this folder and then right click on it, I can create a project within it. I'm just going to call this, let's call it webinar. Right, so now I've got a project called webinar, and because it's a new project, it's opened up a control panel here. So this is the control panel for this project. It gives me kind of like a process model, pipeline, if you like. Data goes in this end of the pipeline, and out the other end pops the model, and you just need to run this pipeline. So to do that, first of all, at this end, you tell it what text to extract. So I'll go and find some data that would be good to look at. Well, that's a very large set of journal articles. That was a set of COVID, research about COVID, but it's around 25,000 PDFs, and it will take too long to run today. But that was an interesting set of data, which we ran during COVID, create a concept map of that. This is another set of data. This is actually a website about a car, and you can see all these HTML files. And my interest there was to create a concept map around a set of documents, like a manual of how to maintain your car. And the idea was to create a systems model of a car just by mapping the manual for it, the text describing its maintenance and design. And it works quite well. So huge range of sorts of data you can analyze, lots of reports. So inquiries by the Australian Competition Commission into the electricity industry, a lot of submissions to that. The Royal Commission to Aged Care. federal election coverage. So there are lots of things you can do with it. But just for now, I'm going to look at just that Royal Commission, I think. So this is those 22 days of transcripts that I mentioned of a commission of inquiry into a disaster. So, okay, so again, what did I do? I went and found the data, I dragged it across into this area of the map. Now, what I did is I pulled a whole folder across. So this is a whole folder of documents, which I found on my disk. You can pull over single files, but it's more effective if you have a lot of data, is to put it into folders and drag the folders across. What sorts of text can Leximancer analyze? Well, it can analyze PDFs, Word documents, plain text, HTML, and CSV files, so those exported spreadsheets. This is actually plain text data. So once you've selected the data, this node will turn green. That means it's good to go. So just to get going for your first map, you would then click on the last stage called Generate Results. And it will do the intervening stages that are blue, that need running. Later on, we would, as an expert, you would change the settings in the various stages, and you can run each stage one by one and then look at the results. So I'll show a bit of that after this is finished running through. And I can see down here, it's going through its paces, and the nodes are gradually turning green as it does the different stages of content analysis. And it's all it's doing, right? So here it's pulling the text out of the files and segmenting it into text segments. It's looking for sentence breaks. It's looking for paragraph breaks. It's also looking for proper nouns. So names of people, places, and organizations. Then here, these two stages, it's building the code book. So what Leximancer does, it extracts the important keywords in this stage here, and you can inspect them, and they're called seeds. So concept seeds are actually keywords, the most important words in the discourse. Then the machine learning learns all those additional words. So you saw the concept of rifle before. This finds all those additional words for each idea and weights them. So by the time it reaches here, you have a code book, a set of concepts that have been extracted from your data. And now at this stage, it's doing the coding. So it's going through and classifying every two sentences with, well, what concepts are they talking about now? It then counts the co-occurrences and builds what's called a concept co-occurrence matrix. So remember, so this is code book. This is a book or a dictionary or a thesaurus of concepts. It then codes those into the text and comes up with a concept co-occurrence matrix. So we can actually look at that. I might do that now. So if you want to see the output of the coding process, you can go into data exports here. And let's have a look at this one here, number 5 in the data exports. It's actually a CSV file that's trying to download for me. So I'm going to download that CSV, and then let's go and find it and open it with just a spreadsheet. So I'm going to open that in Excel. So this is this is a key data structure, not just for Leximancer, but for most types of high-dimensional, multivariate data analysis. You'll see this when people do market research, when they do multidimensional scaling, many sorts of analyses where there are lots of variables, you'll get this sort of data structure. What do I mean by a concept co-occurrence matrix? Well, it looks like a spreadsheet. It has concepts down the left, concepts across the top. It's the same set of concepts. So I can see here pipework, LPG, tank, pipework, LPG, tank. So it's the same set of concepts down the left as across the top. And each cell records how many co-occurrences there are. So risk codes into 105 text segments along with LPG, okay? It goes into 60 text segments with tank. If I look here, this is the plain count. So risk occurs in 947 text segments overall, and 158 of those occurrences of risk co-occur with pipework. So it's showing the way, how often concepts appear in the text as codes and how often they appear with every other concept. And can you see that this is the basic data for a network? Remember, a network has nodes. Each one of these concepts is a node, and it has connections between pairs of nodes. So here's a connection between installation and pipe. So this is the basic data structure for the network. It's required a dictionary, a code dictionary or a thesaurus to pick the concepts, to then classify them into the text and work out how many times they co-occur. So if you like, this is the underlying result of doing a Leximancer content analysis, is this data structure. And it's there for you to export yourself if you want to do some sort of analysis with it, other than the types of analysis Leximancer will do. So we've got a couple of types of output here. One's the topic guide. This is pretty new. So this is a way that we package up the concept network in a pretty, it's a fairly advanced and sophisticated network model that underlies a topic guide. This actually is a network of concept pairs instead of singles. It's called linked community modeling. What it does mean is that a concept can occur in multiple places in your map. And that's really useful with text because concepts aren't just used necessarily in one way. They can be used in multiple ways. So in this text, let's have a look. So I can see pipe work here. I've got control, pipe work, valve, tank, and service here as a point, as a line item within a topic. But I can see pipe work here also, along with steel pipes being underground. So there are a couple of ways that some concepts are used. And this model allows that to happen. So what this is, it's a topic by topic breakdown of the text. And I can see over here for quantity. So there's 1,000 places in the text where this topic is used. And we can look at that. So you can see here the top topic within this data is corrosion protection. It is certainly really important. It is the key to this whole inquiry. And so if I click on that, I can drill down to text to see all the places where this topic is covered. And you can see which document it came from, which day of the inquiry. If I want, I can click through to see the actual text. This shows me that for this particular day in the inquiry, they talked a lot about this idea of corrosion protection. And I can work through, page through all these mentions of this idea. And I can print them out too with their highlighting. So, and you can see that the various topics, and they're in decreasing order of importance. So if I scroll down, you can see this indicator, this little bar graph here is dropping as they become less and less frequent. So it's one way that you can do a guided read through of the important topics within the text and see how they're linked. So supply to the customer, responsibility is covered in this topic here. And we can review that. So that's the newest report that Leximancer has in Leximancer 5 is the topic guide. It's meant to be pretty simple for a non-analyst just to work through these topics and read them in the text. Then there's the more traditional, the classic Leximancer concept map, which is kind of what you've already seen on the slides. And so this is the real, this is the concept network. And So you can easily overwhelm people with the concept network. I mean, it is a good model of the small world network from the data. But the basic truth is that 22 days of transcripts, that's a complex information space. So it's a complex network. It's just inevitable. So there are tricks where you can make this a simpler task to work into this. So what I've done here is I've used this slider to hide the concepts. Each one of these gray dots is a concept. You see here, the gray dot, the label. That's a label for a concept. So concept, customer, tank, responsibility here. And the size of the gray dot gives you an idea of the connectivity. So how general, what are the most general concepts? The ones that connect it all together. Well, these, the ones with the big gray dots, the first to appear are the ones that hold it all together. So LPG, pipework, pipe, and tank. And you can reveal the most central connected concepts. It's kind of like looking at mountain peaks. You can see what are the tops, the highest mountains in your concept space that connect it all together. And that shows you like that this region is dominated by evidence and paragraph and inquiry. So that theme is this area of the map, so we call this bubble, these big circles, the colored circles, we call them themes. They're actually clusters of concepts. And so this cluster of concepts looks to be more about evidence giving in the inquiry. Evidence, paragraph, inquiry. We can bring in more if you want. So you can see here, looking at reports, pages of documents. So yes, it's definitely about evidence giving, legal procedure, if you like, in a more abstract way. So I think if you don't remember anything else, renaming the themes on the map and working out what the theme means so you can give it a good name. So you might call this legal procedure. It's an important part of the sense making. So you can look at it, without the concepts to get an idea that this seems to be about material, the material of the world. This is about legal procedure. This is probably a connection between the two, between legal procedure and the engineering infrastructure that we're talking about here. So this seems to be about health and safety and risk. Health, safety, risk assessment, site visits. So, how do lawyers in a courtroom, how do they control the world of basements, floors, and buildings to control risk? Well, one way is they do it by compliance and health and safety. So this map it's showing that. And sorry, I'm going to sneeze. So when I talked about a factor earlier, this dimension here, which progresses from the engineering infrastructure through to the legal procedure, it goes via health and safety. So the connection between legal and the real is compliance. And without compliance, the lawyers would just be talking to themselves and everyone would ignore them. But because there are laws and regulations that have to be complied with, then we as society use the courts and laws to control risk. So there's a high level story which can emerge here if you can read this map at a high level. So on the right hand side, you can see some of the more quantitative aspects. So the frequency counts. So what are the most frequent ideas, word-like concepts? Pipework, tank, gas. You can see the frequency ranking here gradually dropping. These are the name-like concepts. So what are the important named entities in this data? There's Calor, which is a company. There's ICL, which is another company. There's the chairman, who's obviously important, and LPG, which is an acronym, of course, for a type of gas. And if you want to, you can then click on a concept like LPG or pipework. We could click on tank and see what it's related to in the network. I mean, you can, of course, do it in the map as well. So if I click on tank on the map, you can highlight the rays, those links. What that's showing you is where concepts co-occur. So tank co-occurs with valve and pressure and test. You can see those links quantified over here. So again, tank co-occurs with valve and customer, supply, pressure, test. So I've selected tank, and these are the concepts that co-occur with it. This gives me a very quick idea. Very quickly, I can understand the ways which tank is used in this data. So remember, this is not about understanding, well, you could try to understand how tank is used in this data, but the way to do it is looking at the various sensors that it's used. It's used along with the tank, the valve, but it's also used alongside responsibility. So tank and responsibility, let's have a look at that. So here's tank, co-occurs with responsibility in 62 text locations. If I click on 62, I can see all those places in the text where it's used. The concept of tank co-occurring with responsibility. So I can do my sense making now and work out what they're actually talking about here with this relationship. And I can click on add to log to put some of those in the logbook, which is like a diary. It's a memory of those pieces of text that I think were important. And if I want to go and find those, I could do view log here, or I could go up to the tabs here and go to the fourth tab, which shows me the logbook of all those pieces of text that I've tagged as being interesting. Maybe they're quotes from my report. So while I've got your attention up here, you can see there's quite a lot going on up here. We've seen the concepts tab. You can see here I'm looking at the selected concept tank. If I want to go back to the master list, I hit ranked view, and this shows me the master list of concepts. If I want to look at how the concept's defined, I can go to the thesaurus tab here, and this shows me how, let's have a look at building as a concept. It's one of these latent concepts that I mentioned before. So building is an important idea in this text, and I can see here are the words that predict that they're talking about a building. So this is how it codes. This is the words it looks for to code for the idea of building in the text. And what it will mean is somewhere, in this map, you will find places that are coded with building, but they don't use that word. They use other words like assembly, L-shaped, pathway, footprint. These all indicate that they're talking about the construction at the site. There's a query tab here. So every time I click on a concept, like I showed you before, so if I do want to find all the places in the text which are coded with a concept like safety, I can just go back to the concepts, make sure I'm on the ranked concept list. And if we go to safety, click on the number there, 679, I can see all 679 of those places in the text. And when I do that, if you look up here, that's flipped me to the query tab. So whenever Leximancer is showing you text segments, you're in this query tab actually. And you can use that to search for you can do your own searches in this query. So if you want to search for where three concepts are used together, you can enter them in the bar here. So I want to look at where the concept, the word-like concept safety, and the word-like concept health, where they're used together. I can do this sort of built-in query. If you hover your mouse over the search button, it gives you a bit of syntax about how to type your queries in here. But let's just hit search. And I must have mistyped that. So there's also a little gadget here at the top of the concept map. If you can't find a concept, say I want to find the concept health here. That's interesting. Oh, that's why I couldn't find it, because it's not there as a lowercase concept. They mustn't, yeah, so they mustn't use it by itself. All right, so that tells me what I did wrong there. I went with my search when I was doing that. That actually doesn't exist. So we could try something else. We could try report. Find something there. There we go. So safety, concept safety and concept report, and that brings back the intersection between those two concepts wherever it occurs in the text. And you can browse through all of those. So there's quite a lot going on here. To make your sense making easier, we include the analyst synopsis here. So for every theme on your map, you get an item here in the analyst synopsis. Gives you a little bar chart, shows you how important it is, how many text segments supported. You see there are 8,000 pieces of text which support the pipework theme, which is this red one. So the colors match. So the red theme here matches that red item there. And if I click on like pipework, it takes me down to a list of the concepts that are part of it. There's you can quickly read a story off here. What is the pipework theme about? It's about these things. Underneath, we can see the top 5 pieces of text which support that theme. If I want to deep dive into this idea, I click on the list of concepts and it shows me all those 8,179 text segments which support that whole theme of pipework infrastructure. Again, I come back to, you should come up with better names for these themes. The reason Leximancer chose pipework as the name of this cluster is simply because it is the most connected concept in the red bubble. So you can see within the red area on the map, it's the first one to appear. And that's the reason Leximancer made this the name of the theme. But it doesn't mean it's the best name. And I would advise, go and have a look at the theme, read down into it and work out what they're actually talking about here to give it a better name for your report. So don't necessarily stick with the theme names that Leximancer gives. They are just the most connected concept within each cluster. I guess I've got to wrap up. I guess finally, though, I should talk about this theme size just quickly, because you're probably going to wonder why it's there. I use themes usually between about 50% and 65% usually, but you can change it down. So we could take it down to like, wherever, 35%. So what it does now is it makes the bubble smaller. This is an example of a research technique called hierarchical clustering. So hierarchical clustering takes this sort of data where you have items in a network. We know you've seen the data structure, the concept co-occurrence matrix. You've got a similarity score. How similar is each concept to every other concept, and then the system does a hierarchical cluster on that. So it works out what are the most similar concepts, puts them together into the first level of clusters, and then it groups those clusters together. And then those clusters are clustered with the other clusters. So it gradually groups them all together until, right at the end, you've got just 2 very big clusters. And at this level, you can see the dichotomy between legal procedure and engineering reality. It's a very high level, but it is one way of is one true way of looking at the data. It's not the only way, of course, but it does show you that there are two lobes to this distribution. There's a region up here and a region down here. But you might not want to operate at such an abstract level. So you might want to try, what 75%. So that breaks it down into three. So I can see a dichotomy there between legal procedure, engineering reality, and the organizational aspects of the company as an organizational reality. You might ask which is right. Well, they're all right. It depends. It depends your research question, your audience, whether it fits. And you'll find that some ways of hierarchical clustering fit better than others. So, if you need to, go and have a read about the method of hierarchical clustering and how you choose what level to cut your model at, whether you have just a few very high level concepts or a lot of very specific concepts. I would find it hard to model at this level. There's too many. So